All right, so this is the second part of the gas stoichiometry video. So this is the last problem in your notes. So we have 45 grams of lithium metal react with 8.23 times 10 to the 24th molecules of water. Calculate the volume of gas produced at 4.5 degrees Celsius and 292 kilopascals. So first thing we need to do before anything, we need to write out our equation. So unlike our last problem, this one we do not have our equation already written out, so we need to make sure we write that out. So we have lithium plus water, and if you look at your reaction sheet, that's going to give you lithium hydroxide and hydrogen gas. So it's going to be the hydrogen gas is what we're going to end up being solving for. Go through and balance. All right, so we have 45 grams of lithium and then 8.23 times 10 to the 24th molecules of water. And we are trying to find our moles of gas. So for the first part, we need to do our stoichiometry. Now, this is a limiting reactant problem, so we're going to have to do two stoichiometry problems, one for each of the reactants. So let's start out with our lithium. So we're going to go from grams to moles of lithium, and that's going to be molar mass. So lithium is 6.94 grams per 1 mole. And then we need to use our mole ratio to go to hydrogen. So it is 2 moles to 1 mole. Two significant figures to start with. So when you calculate, you get 3.2 moles of hydrogen from that lithium. All right, we're going to do the same thing with water. Now, the only difference here is we're starting out in molecules. So instead of using mass, we're going to use Avogadro's number to get to moles. So 6.022 times 10 to the 23rd. And then again, once we're in moles, we can use our mole ratio to go from moles of water to moles of hydrogen gas, and it is a 2 to 1. Okay. Here we have three significant figures, so our answer should have 3, and you should have gotten 6.83 moles of hydrogen. So looking at our two amounts, which one is the correct number of moles of hydrogen? That's going to be the least amount. So it is the 3.2 moles of hydrogen. So there's our moles of gas. Now that we have our moles of gas, now we can use PV equals nRT. Okay, so we're always going to be solving for volume here. Our moles we just solved for, so 3.2 moles. Pressure, we're going to look back up here. That's 292 kilopascals. R 0.0821 liters atmospheres per mole Kelvin. Temperature 4.5 degrees Celsius, which again we need to change to Kelvin. And then there's one more thing we need to do with this one before we can plug our numbers in, and that is our pressure. So our pressure is in kilopascals right now, and we need it in atmospheres. So we're going to change that into atmospheres, so it's 101.3 per 1 atmosphere, and you end up with 2.88 ATM. Okay. All right, so now we can plug our numbers in. So our pressure, we're looking for volume 3.2, R value, and then temperature 277.5, and then just solve for volume. Now, we should only have two significant figures because our temperature is only in 2, plus we started out with only 2 here with our mass of lithium. So you should only have two significant figures, which you should end up with 25 liters for your volume.